Okay, let's use the properties of cubed roots. Now this is very, very similar to square roots, only we're talking about the cube root. In other words, let's talk about the perfect cubes first. 1 cubed is 1, 2 times 2 times 2 is 8, 3 times 3 times 3 is 27, and so forth. So the opposite of a perfect cube is a cube root, all right? So if I say, well, what's the cube root of negative 128? Negative 128 is not in my list. It would fit in between these two. So what you want to do, and I know you could just stick this in your calculator, but I have to show you how to do it without using the cube root on your calculator. Some of you may not even have a cube root on your calculator that you can find. But I'm going to divide 128 by 125, which I know it won't go in there because there's only, it's just 3 away. But then I'm going to divide 128 by 64. I want to see, will that work? So 128 divided by 64 is 2. So it did work. So what I'll do is I will break this down into, and I'm going to go ahead and use a negative 64 times the cube root of 2, because 64 times 2 is 128. All right, and it is okay to have a negative under a radical sign as long as the index is odd. If it's even, it's not going to be a real number. It'll be an imaginary number. Now, the cube root of negative 64 will be 4, because 4 times 4 times 4 is 64. So I'm going to pull a negative 4 out from under the radical, and then this cube root of 2 will remain in the radical. So negative 4 cube root of 2. You might want to write that separated enough so that it doesn't, you don't get confused that 3 is going with a 4 and not the square root of 2. So be careful how you write that. All right, now we have the cube root of 125x to the 7th. And very much like the last video, I've got some variables here that I'm going to deal with. So 125 is, the cube root of 125 is 5. So I'm going to factor or pull a 5 out from under. And then the cube root of 7, instead of 2 like we did with the squares, I have to pull them out in sets of 3s. So 7 divided by 3 is 2. I can pull 2 x's out, but 1 x will have to remain up under the radical, the cube root sign. So 5x squared cube root of x. Now, to explain that a little bit better, the way I did before, if you write down 7 of these, and I know that's kind of annoying, but just to try to make you understand it, if I write 7 of these cube roots down, it takes 3 to pull 1 out. So that x is now freed from the radicals. 3 more pulls 1 out. So that's the reason there are 2 that get to come out from under the radical, but only 1 of them stays up under the radical. Okay, now let's do the same thing with the fractions. I can separate this to the cube root of y divided by the cube root of 216. And the thing is, I don't want a radical in the denominator, but 216 happens to be in the perfect cube list. So it becomes 6. And the cube root of y, there's not 3 of those, so it has to stay up under the radical. And you're simplified at this point. And in this one, I'm going to separate it as well. And 27 y cubed, well, the cube root of 27 has 3, so 3 comes out from under the radical. There are 3 y's up under the radical, so the y will also come out. And then up here, the cube root of 8 is 2, so he comes out. And then 1, there are 4 x's here. I know 3 has to be pulled out, so 1 x will come out, and then 1 x will remain up under the radical. So 2x cube root of x over 3y.